In last video, we did the first application of Gauss law, that was to find electric field intensity due to a long infinitely straight wire. Now, in this second application of Gauss law, we are going to find electric field intensity of infinitely long charge sheet. To derive this expression, we will follow the same steps that were followed in the previous derivation. The first step that we did in previous derivation was to make a Gaussian surface, that is an imaginary surface due to which, with help of which we are going to find electric field intensity of this charge sheet. Now, the Gaussian surface that we have to make here is again cylindrical shape, but in last case it was surrounding the wire. In this case, the Gaussian surface would be passing through this sheet. So I'm just making a diagram over here. So cylinder will pass through this sheet from front to back. So I will be making with two different colors. So I have updated a diagram with a Gaussian surface that is cylindrical in shape, which is passing through the sheet. The red part is in front and the blue part is in the back of the sheet. Sheet is something, a 2D rectangle. You can, for example, you can see your book. If you place it vertical, it has two sides, a front side and a back side. Next thing I will be drawing here is the electric field direction. As it is a positive charge sheet, the direction of electric field in front would be like this. That is outside or outwards, and from the back side also outwards, because it is a positive charge sheet. It is positive from front side also and from the back side also. So I would just write E over there. Okay, so I have made direction of electric field also. The next thing was to give to represent area vectors on the Gaussian surface. As it is again a cylindrical Gaussian surface, there are three area vector that we have drawn in the last video also. One would be representing this face, one would be representing this face, and the third one would be representing the curved part. Those who face confusion in this can see the last video. Now I will give direction to this. Direction is always outwards, outward, and again outward. These are the three area vectors that I have made over here. This is again dA. Okay, this is dA. And this is again dA. So three area vector I have made over here. Now I will give name to these faces where I have made area vector. Let it be first, let it be second, and let this be your third. Okay, now if you remember, the step that we have taken after giving names was to find the flux with the formula E dot dA. So I have separated my dA into three parts. So flux is also separated in three parts. That is phi is equal to just as it was in last video or last derivation that we have done of Gauss application. E dot dA plus E dot dA and plus E dot dA. You can give name at the base of integration to classify them more precisely. That this is first integration of first part, second part, and then third part. Done. Now E dot dA, you know how it is opened. EDA cos theta. Now you will just see the angle. For the first part, they both are in same direction, that is 0 degree. DA and E are at inclined at 90 degree. And for the third, they are at again 0 degree. DA and E are in same direction. So cos 90 is 0. So second part would become 0. You will only be left with EDA plus EDA. Now EDA plus EDA would be equal to 2 EDA. So this would give you equals to 2 E integration of dA. Now integration of dA is A. So you can just write down EDA is equal to 2 E into A. Fine. Now you can make this your equation 1. Now you have to apply Gauss law. Just you applied in your last derivation. If you apply Gauss law, what you will get, that flux is 1 by epsilon times of Q, right? So we can write that phi is equal to 1 by epsilon naught into Q. Now Q, in case of a 2D figure, if you remember the last video I told you about continuous charge distribution. Sigma was Q by A, so Q is sigma A. So this would give me 1 by epsilon naught into sigma A. Now you just have to compare it. You have to compare both the equation, one in this one and this one. So if you compare, what you get 2 EA is equal to 1 by epsilon naught into sigma A. So area and area cancel out each other from both sides, and the formula of E in this case comes to be sigma upon 2 epsilon naught. So this is the formula for electric field intensity of infinitely long charge sheet.